In this recording, we're going to learn about fractional exponents. And rather than tell you about them, I'm going to have you do an exploration, a discovery on your calculator. So please write down everything that's on the screen. When you're ready, if you have a graphing calculator, grab that and then play the recording. Okay, hopefully you wrote down everything that's on the screen and have your calculator ready. If you don't, there's some free online graphing calculators that you can access. On our calculator, we're going to do 16 to the 3/4 as well as the 4th root of 16 cubed. Okay, so to get that, you're going to go to Math, choose choice 5. You want to cursor over on top of ants, delete it, and type a 4. Under the radical, we're going to do 16 cubed. That's your number. Then I'm going to do 16 to the exponent, that is a fraction, 3/4. Not quite. I didn't really want to do it that way. Let me get the 4 down the denominator, like that. Okay, they're both 8. All right, let me grab that. Let's try this one. Let's do the cube root of 27 squared and 27 to the 2/3 power. So we'll do the cube root. That happens to have its own button. Of 27 squared, 9. Well, that kind of makes sense, right? Because the cube root of 27 is 3. 3 squared is 9. Cool. And then we'll do 27 to the 2/3 power. So again, create a little fraction. Also 9. So given that these are equivalent on the right, these expressions on the left must also be equivalent. How can they relate? I'm looking for you to make a connection with what you see in terms of the bases are being equal and the fact that there is a root here. We call this the index of the root, and we have a power here, and over here we have an exponent that is fractional, and I'm sure you see all kinds of connections here and are ready to make a conclusion. Okay, so this is equal to this is equal to this. All right, cool. What do you notice? Well, hopefully you notice that the 2 in the numerator over on the right side is still the exponent, and the 3, the index of the root, is the denominator. Okay, so sometimes people say power over root. Okay, sometimes people say it that way, power over root, and you can think about it in terms of alphabetical order. Power over root. All right, the root is like the 4th root, right? And this is the 3rd power, P over R, power over root, alphabetical order. Another way to think about it is the 4 here makes the overall answer smaller, right? When you're doing a 4th root, just like having an exponent with a denominator makes it smaller, whereas having an exponent in the numerator makes it bigger, and the exponent over here obviously makes the number bigger. They have the same effect. Okay, so let's conclude. Mathematicians, we like to conclude and write things in general form with no numbers. We like to write in terms of just letters to represent any number. Okay, so write down what's on the screen. Please play the recording when you're ready. Okay, so in conclusion, I would like you to write something here with B's and P's and Q's that is in radical form. And over here, I'd like you to write something with a fractional exponent. So have a little exponent that's a fraction, using A's and M's and N's. Okay? Play the recording when you've got something written down. Feel free to flip over to the other page where you had actual numbers as your reference. Okay, so hopefully you said, okay, the bases are the same. So we've got B, and we said power over root. So Q the qth root of b to the p power. We said power over root. So power m over n, and of course the base is still a. Power over root p over r, alphabetical order. Power over root. Okay? So let's apply that a little bit. Our task here is to write them in radical form and then simplify them. Okay? So I'll get you started and then I'll give you a little practice time. Once you write down the directions, it says write in radical form and then simplify. So in terms of a radical, there's my radical. There's 25. The question is, where's the 1 go? Where does the 2 go? We said power over root. So the 1 could go right here. You can write the 1, but remember, 25 to the 1 is no different than just 25. Here's where you want to concentrate. If you're spaced out, tune in. Don't write the 2. You've never seen a 2 there in your life, and you won't see one in this class. We don't write the 2. There's no such thing as the first root. So if you don't have any root here, it's implied that it is a square root. Let's make a note to ourselves, and if you have another color, that would be a good time to use it. Make a note to yourself. Don't write 2 as the index for square root. It's implied. Okay, so you'll never see us write the 2. We just say, okay, if there's nothing there, it must have been the square root. And of course, what does that simplify to? The square root of 25 is just 5. So that's how we're going to do these. We're going to say, write it in radical form, then simplify it. Okay. All right, the next one, we're going to go root 27. So power over root. Put our 1 and our 3. And the cube root of 27 is simply 3. You could find that on your powers table. That was the whole point of having our powers table, is we'd be able to look up at 27 and find out what its cube root is, because it's under the perfect cubes. All right. Next one. We said anytime we have an exponent outside a fraction, we're going to distribute that exponent to both the numerator and denominator. So our first step will look like this. 16 to the 1/4, 81 to the 1/4. All right, and then I'm going to make that 4 a little better. Sometimes my 4s look like 9s. All right, and then we're going to simplify that. Power over root. So 16 to the 1, but we're taking the 4th root of it. All right, 81 to the 1. Don't have to write the 1 if you don't like to. All right, you need to look up on your powers table, on your blue card, find 16 under the x to the 4th column. And then backtrack to the left to the x column, and you will see that the 16 is the 4th power of 2. In other words, the 4th root of 16 is just a 2. And then for the 81, you'll also find that under the 4th power column. So the 4th root of 81 is just a 3. Now you might be saying, well, couldn't I have just done that on my calculator? Sure, you could have. It would have worked out. You just put that in your calculator, it'll come up with this. What we're trying to get to is an understanding of how these fractional exponents work so that we could do questions like the following page that have no numbers as the basis. All right. Next 2 questions, I want to see if you can do them on your own. Play the recording when you've got your answers. Okay, so this one, 64. We said power over root, so power root. Let's have, did we write the 2? No, we don't write that 2 there. Hope I didn't catch any of you there. Don't write the 2. All right, so square root of 64 we know is 8. And then 8 cubed, well, I think that's 512, if I'm not mistaken. I'm going to grab my calculator real quick and punch that in. 8 to the 3rd power. So I don't have my powers table extended quite that far. Yep, 512. All right. So then The next one, we've got 8 power over root. All right, so cube root of 8 we know is 2, and 2 to the 4th we know is 16. Okay. Last one has a negative exponent. So because it's a negative exponent, that means go to the denominator and become a positive exponent. Now that's in the denominator, we can say power over root. So 3 is our power, our fourth root. All right. Fourth root of 81. Remember that? That was over here. That was a 3. So 3 is in the denominator cubed. 3 cubed is 27. So 1/27th is our simplified form. All right. I'm going to see if you can put each one of these into exponential form. And then play the recording when you've got the answer. Okay, so our first one, hopefully you've paused and put these in exponential form the best you can. So it would be m to the 1/4. You might be saying, where's that 1 coming from? Well, if there's no exponent, it's there. And this is a big mistake folks make, is they don't put that 1 in. Well, it can't just be, it would not be equal to m to the 4th, right? That wouldn't make sense, that the 4th root would be the same as the just m to the 4th. It makes no sense at all. So clearly, maybe I'll just leave that in there. It's not that. It's not m to the 4th, okay? Don't do that. All right, so for this one, power 3 over root. Well, what would be the root? There's nothing there. Well, it can't be to the 1 because there's clearly a square root there. So there's got to be an implied 2 as the root. Be careful with that one. This one's pretty easy. Power over root. This one, slightly cumbersome. You've got 2 separate factors. The 2 has an exponent of 1. So when you get to the 2, it's 2 to the 1/4 power over root. The v has a separate exponent, 5 over 4 power over root. So be conscious of that. And our last one, they have the same exponent, so you can treat them together in a parenthesis. So here we go, power over root, 7 over, well, there's nothing there. Remember, that's a square root if you don't see the root written. Thanks for watching.